Question 9. A. State the reactants and conditions for the two different types of reaction that both produce diethylamine. Okay, this one. Before we start this one, you need to know the preparations of amine. Generally, we use the three methods to prepare amine. First, we use halogenal alkane with ammonia in ethanol, heat under pressure, so it will form the amine and the HCl. So it's basically the one of the H here reacts with Cl, form HCl, and the NH2 will bond with this CH3 to form this. Second method is the reductions of amide. So we need to use a reducing agent, lithium aluminum hydride. So the amide will remove oxygen and add two hydrogens there. So it will form the amines as well. So another method is need to involve nitrile. So we use the halogenal alkane reacts with these cyanides in ethanol, heat under reflux, and it will form the nitrile. Once it's formed nitrile, we need to reduce it. So this carbon will get two hydrogen, this nitrogen will get two hydrogen, then it will form amine. From this preparation method, is quite clear that the last method is not really that suitable because when it's involved cyanide, so the cyanide here need to after it's formed the nitrile, the nitrile group will reduce to CH2NH2. So the ethyl group is relatively hard to form in this case, and therefore it's better for us to use these two preparation, the first one and second. Let me show you in another piece of paper so it's easier. So in order to form the diethylamine, because it's two ethyl group, we must make sure for the first method, we must make sure the compound contains ethyl group. So the halogenal alkane, we need to use the chloroethane. Let's say this one, chloroethane, because chloroethane there is a ethyl group there. And the amine itself also need to have one ethyl group. So we use ethylamine. And this reaction mixture is also in ethanol, heat under pressure. So during reactions here, the HCl will combine and removed, and new bonds form between this C and this N. So means to form this bonding, and therefore it form the diethylamine. So means we need to use these two reactants. And another method is the reduction of the amide. So we need to make sure the one ethyl group bonded to the N in the amide group, and the another side here it must be two carbon, means we need to use the 4 carbons amide. So 2 carbon with this ethyl group, and this ethyl group bonded to N. Another 2 these 2 carbon, it must be for inside the amide groups, means this CH3 and this CO double bond, right, in amide. So after that, we use the lithium aluminum hydride as reducing agent. So this one will remove oxygen and add 2 hydrogen, then it will form this diethylamine. So therefore, the answer is quite clear. So this is actually in the mark scheme. So this is how and why we use this. Chloroethane and ethylamine in ethanol, heat under pressure. So reaction 2, which involve amide, you can give the name N-ethyl ethane amide. So means this ethyl group bonded to N, so we call N-ethyl. And this amide here, this main structure is has 2 carbon, so we call ethane amide. Of course, the reagent is the lithium aluminum hydride. For the part B, describe the relative basicity of diethylamine, phenylamine, and ammonia in the solution. So first, you must know the structure of these few compounds. Dimethylamine is no issue because in the earlier part. Phenylamine, of course, you must know is one benzene ring with NH2, and ammonia, of course, everyone knows. So let's discuss the one that the most basic. Okay, which one is the most basic? The basicity, it depends on how available is the lone pair on the nitrogen. So we know that ethyl group is electron donating, so it will donate electrons to these nitrogens and the lone pair. So it will let this lone pair more available. When this one is more available, then it's more likely to react with the H+. So therefore, it's a most basic amine. And which one is the least basic one? Of course, it's the phenylamine. By now, you should know that the NH2 is an electron donating group, which it will donate its lone pair to the benzene ring. And when the lone pair on the nitrogens delocalize in the ring, means sometime it won't be there. So it's we say that it's less available. When this lone pair is less available, then it's less likely to bond with H+. Means this is a weakest base among these. Of course, ammonia is stronger basicity or higher basicity than the phenylamine. So this is a trend. The most basic is diethylamine, followed by ammonia. After that, the last one is phenylamine. Explanation. In the mark scheme nowadays, they just put point form. Sometimes it's hard for you to relate. So you just follow mine, and you can understand better. Okay, in the diethylamine, okay, this one, the diethylamine, the ethyl groups, they are electron donating, and this will make the lone pair on nitrogens more available to gain electron or to receive, to gain H+ or to receive H+. In phenylamine, the lone pair on nitrogen overlaps with the pi electron system in benzene ring, and therefore it makes it less available to gain the H+. So it's less basic. For the part C, phenylamine reacts with the HNO2, so at 4 degrees C to form compound P. Compound P reacts with phenol under alkaline condition. At 4 degrees C, the product of this reaction is acidified, forming azo compound Q. Draw the structure of Q later, the last part. Circle the azo groups on your structure. State one use of azo compound. Before you give the compound Q, of course you need to know how the reaction works. First, the phenylamines, when it reacts with HNO2 at 4 degrees C, so it will form this benzene diazonium ion. This is P. And this benzene diazonium ion will react with phenol, and this phenol need to form phenoxide first. Means when phenol reacts with this hydroxide or alkaline, so it will form this phenoxide. So it's actually more active, we say that. So it will activate the ring better. After that, so this phenoxide or this phenol, it will react with the benzene diazonium ion. So because this one is electron donating, it will direct 246. But for this coupling reaction, means for this reaction, the P will direct to the fourth carbon. So this one is first, second, third, fourth. So it will direct to this fourth carbon. And the this is actually electrophilic substitution. So this benzene ring will form bonds with this N, right, in this benzene diazonium ion. And after that, this pi bonds break, lone pair restore on nitrogen, so it will form these compound, form the double bonds, right? So it will form this compound, which is Q. So this is a compound Q. So this compound Q is the azo die, and circle the azo group in the structure. So the azo group is this one, the NN double bond. And the use of this azo die is, azo is actually a die. So the function is correlating agent or die. For the part D, so now we have diethylamine again. Now reacts with this acyl chloride, or we call ethanol chloride, CH3COCl, and this will give the amide NN diethyl ethane amide. This one. From here we know that this is the nucleophilic addition eliminations reaction. So first, in order for these amines reacts with this acyl chloride, must start with the partial positive negative. So you just put the partial positive on the this acyl carbon, and partial negative on the oxygen, and partial negative on the chlorine. This one might not be really needed. Okay, you must show these two. And of course, the lone pair on nitrogens must show. And draw an arrow from this lone pair, point to this acyl carbon, and after that, pi bond break, means draw one arrow from this double bond, point to the oxygen, to show that this pair of electrons move to this oxygen. Then it will form this intermediate in the box 2. For this intermediate, a few steps you need to do. Okay, first, please put a charge positive on the nitrogen, because nitrogens donates a lone pair to form bonds with this carbon, and nitrogen with 4 bondings, you just put positive charge here. And of course, you must put the lone pair and charge negative on this oxygen. So this is the oxide now that form after the first step here. And you must draw one arrow from the lone pair point to the CO bond. It shows that the pi bonds will reform, and CCl bond therefore must break. So CCl bond break, then it will form chloride. And another things you need to do is you must show the NH bond break. Draw one arrow from the NH bond, point to the nitrogen, to show that the lone pair on the nitrogen restore. After that, H plus will release. H plus and the chloride now combine to form HCl. Okay, so this is a full mechanisms for the reaction. I hope you understand. And these are the guidelines. You just follow, you'll get exactly what I told you just now. And part 2, name this mechanism. This mechanism we call nucleophilic addition elimination. Okay, that's all. Thank you.